In today's episode, I sigh. We walk in a field, I huff, there's soup, and I reach peak excitement.
It's been over a year since we've last seen each other, and you, as well as our friends and family, kept asking us the same question over and over again. When is the next video going to be released? And how is the boat project going? And how is editing going? And how is the boat? How's the boat? How's the boat? Well, truth is, we're both perfectionists, and this took us way longer than expected. There was just so much footage to go through, and we were really struggling on how to tell our story. And in Dutch we have this saying, wat in het vat zit verzuurt niet. Meaning that if you have something that's good, and if you keep it well, then it will still be good later on. So with that said, we are very excited to be sharing this first episode of the upcoming season with you. Before we'll show you the barn find yacht, we'll take you back in time 6 years. We were having vacation on our small motorboat in Spain, but we'll tell you about that adventure in a later episode.
And as much as we enjoyed it, we very quickly found out that we would barely get a decent night of sleep, even with the best conditions, just because of how rolly the hull is and how much wave slap the hull experiences on anchor. So we basically found out that we need a bigger boat. Now, we wouldn't mind a bigger boat, but it would then also have to be able to carry us safely and comfortably around the world. To us, that rules out all production yachts. And what is left are really good, very high-end yachts, which we cannot afford, or really high-end yachts that are no longer good, which makes great YouTube. We absolutely love watching those restoration projects. That's not what we want to spend our time on. So the options that are left are either build a high-end boat ourselves or finish a unfinished project of a high-end build.
And that's when we found the ad for the Tasman 48. It was already for sale for 1.5 years. It had a pilot house, which we really liked because we would like to cook up there, watching out of the window. Cooking is a great part of our lives, and also later in this episode we'll show you one of our favorite recipes that we can only cook for a couple of months each year. But now back to the Tasman.
The Tasman 48 is a Van de Stad design. Van de Stad is a great and renowned Dutch naval architect. When we arrived at the yacht, the first thing that we noticed was the brand new old growth Burma teak deck. Now, people that know a little bit about wood know that it is absolutely impossible and I think even illegal to obtain this wood nowadays in that quality. They built the hull by strip planking Western red cedar and then covering it with glass fiber and epoxy on the outside and inside. And then when they were done, they added another layer of Kevlar on the inside for additional safety. So during the viewing, we got totally thrilled. We really loved the boat. It was built like a tank, but the 48 feet, we weren't really sure if our unconventional needs would all fit. Now, since the owner had no other potential buyers, we requested him and he agreed for 2 weeks of exclusivity so we could work on the layout. He provided us with all the technical drawings and I used those to create a 3D model.
Before we get into that, the next day we visited 2 similar sized boats. A Concorde 47.5, also pilot house. But this one had the kitchen downstairs. It was a bit small, but it was really, really cozy. And the other one was a Moody 54 deck saloon. Very, very beautiful boat.
Ouderwetse Moody, zeg maar.
And we also went on a bit larger motorhull, a 60 foot. And we were standing on the bow, looking up that mast, saying to each other, this is way too big. So that confirmed to us that the Tasman 48 would be a good size.
So straight away I took 2 weeks off from work. We already agreed a revisit with the seller 2 weeks later. and I had a whole bunch of engineering questions to answer. For example, there was no keel yet, nor a rudder, and these two objects have a big impact on the shallow water operability of the yacht, and we want it to be very shallow water capable because of the Bahamas. Then there's the question what to do with the tender and what to do with the interior layout that was already started. And the day before the agreed revisit, we were convinced that, albeit a compromise, we could make it work, and got very excited about buying our future home. Now on the day itself, just before departing, we contacted the seller just to be sure. And what he told us is that a person that visited the boat a long time ago sent him a fax, of all things, stating with a signature that he would pay the asking price of the boat. That was it. We weren't able to counter-offer. We were absolutely willing to pay his asking price. So we were devastated. 2 weeks for nothing. And our disappointment, at least on my end, slowly turned into fury. There's nothing that motivates me more than being really angry. We already had this set of drawings. The compromise was all the time that the boat was just slightly too small. And it is very simple to expand a set of drawings for a boat. So I said, fuck it, I'm going to build the whole boat myself. Now with that plan in mind, I was very motivated to kickstart the project, and that would mean to buy as many components as cheap as possible. The biggest thing is the power plant. For this we made a very specific selection of a diesel engine. It's the Mercedes OM606. An icon from the 90s when automotive engineering was at its peak. 3-liter, straight 6, 24-valve, dual overhead cam turbo diesel. Easily modded to produce in excess of 400 horsepower and often converted for marine use. And with good reason, this engine has some strong bones. The stock internals just won't care about you nearly tripling its power. As an inline 6, it's inherently smooth, which is great for boats. And just listen to it. Remember, this is a diesel. The mechanical injection pump from its predecessor fits plug and play, and you end up with a power plant that doesn't need electronics, which is great for reliability at sea. So you can imagine that at low power output, it makes for a strong and reliable, fuel-efficient power plant. Having been a tuner's platform for decades now means everything has stood the test of time, with nothing left unknown. I made friends with another gearhead, Najim, and he kindly delivered the engine we bought from him. He has been so helpful. He thoroughly inspected the engine. He sourced and mounted the older style injection pump for us, and he also arranged some other useful parts. When we first went to see him, I could tell he was like the diesel version of myself, with a garage full of cool stuff and projects. I already bought a higher inertia flywheel from the smaller OM604 and the marine bell housing and engine mount kit. We test fitted them on the spot, as before that we weren't actually sure if the thicker flywheel would fit inside the bell housing. Then I had to build a trolley. As you can tell by the tools that I'm using, and no doubt we'll learn from our next videos, I'm more of a metal fan. I mean the material. I hate wood, or well, I hate doing technical things with wood, but whenever I do, it always feels like I'm cheating. That green thing you see next to the bell housing is a marine reversal gear. It takes place of an automotive gearbox or transmission, but then in a boat. This part is now sold. It and the engine would have been perfect for an enlarged Tasman 48. But since it's undersized for a 70-footer, it's going to become our combined genset and hydraulic power unit. We'll tell you about that in a later video. I found myself really clever when I used the impact gun for the wood screws. As I said, cheating. Don't mind the junk in the background here, but it was time to see if the shitty caster wheels would hold up. Time to really let that full weight down. And done.
The engine was only the start, and in the upcoming 2 years we got many more parts, and with every part I jokingly said, well, you're gonna need to add another foot and another one and another one and another one. And that's when we saw the ad of the 70-foot hull in Belgium. Although this was way too large for us, we just couldn't resist because of the price. And maybe this was a good opportunity. So we immediately went there to check if it was worth buying.
The seller first showed us the only 2 remaining drawings.
Dus maar ik kan ook maal 1.1 zou ik gedaan hebben. Ook 10%. Voilà. De kwaliteit van de
And there it was, magnificent and full of discolored wet spots from years of roof leaks dripping all over, but hibernating for decades. Covered in dust, spiderwebs and mosquitoes from the sewer grate I'm crouching on here.
Door die spierply dat er hier op zit.
Ja, dat kunnen we afklikken. Ja.
Een beetje stof in moet iets voor de stof zijn.
I was convinced this yacht could take us around the world safely and comfortably. It could fit all those parts and systems to do that for us. But in the meantime, well, you just saw huge problems.
So with only 2 days to make a decision on buying the hull or not, we had one big problem to solve. And that was how to get this massive object out of there and relocate it. Plenty of yachts are transported by road, including some really large ones. But those are often short trips, like from a shipyard to the water. We did look into moving her by water, but had to rule that out because of the total cost. International highway transport would mean special oversized permits, a fancy rig and 2 escort vehicles, and that all adds up fast. Additionally, on this route you also have to deal with things like tunnels and overpasses. On top of that, when the hull was built back in the 90s, the shed was still somewhat accessible from the back road. But since then, things like streetlights on that narrow street have been added, so with the fenced off railroad besides it, getting the hull out now would be a massive project all by itself. Of course, we looked into the options, and there are 2 possible ways to load the hull onto a trailer, optimized for height or optimized for width. So let's look at the numbers. We're either talking 5.5 meters wide and 4.5 meters tall, or just under 5 meters wide and 5.7 meters tall. Well, guess what? Permits are barely ever issued for anything wider than 4.5 or taller than 4.25 meters. And you can forget about those tunnels and overpasses. Even if it were possible, it would cost a boatload of money. And then where are we supposed to store it? We don't really have the space, outdoors isn't an option, and in the Netherlands every square inch comes at a premium. Transporting it by road, out of the question, just not an option. The next obvious solution would be to chop the hull into pieces, stick them all in a shipping container ready to be rebonded back together before fiberglassing later on. With this idea in mind, I contacted the naval architect, Vennekens. To my big surprise, he was actually quite supportive of the idea, so there's that. At that point in time, we just didn't have the funds to afford that hull, so we had to get a loan. And then there was the issue of where to store this shipping container. For that we got special permission to place it in the field, under the condition it would be green so it wouldn't be that noticeable. Lastly, we had to get the approval of the seller to place the shipping container on his yard first so we could load it, and he agreed.
After those stressful 2 days, we finally went back to Belgium.
Moet je wachten.
And we bought her. We still couldn't take it easy because the seller only gave us a few months to empty the shed.
I then had to come up with a plan on how to section the boat, and there was one big issue.
The hull is strip length using wooden strips about 1.5 inches thick, milled with bead and cove edges. During construction, the strips were bedded in thickened epoxy and heavily fastened to the layer beneath with 316 stainless wood screws every single foot. With each new layer, the screw pattern was staggered by roughly half the spacing, creating uneven rows of screws at roughly 6-inch intervals along the full length of the hull. Western red cedar is lightweight and soft, and 316 stainless is already a difficult material to machine, but with those screws being so much tougher than the soft wood, you end up with a very nasty intermittent cut, basically the worst case scenario for a saw blade, as the teeth suddenly and violently slam into solid metal, likely full on with the tooth face instead of just the cutting edge.
There aren't many manufacturers that have a solution for this issue. I contacted CMT, and after some technical back and forth, they sent us a box.
They did send us these blades free of charge to test in exchange for some footage they could use on their socials.
Who is that?
I actually had to ask them myself to throw in a t-shirt and a sticker or banner, because if these blades performed, I wanted to be able to give them the credit that they deserve.
So what do we have here? Demolition.
The blades are made in Italy and they use special impact-resistant carbide teeth, and they are deeply braced into the blades with a large contact area for strength so they don't break off easily. From everything I could find, these were our best chance.
Equipped for the most decisive test cut of my life, we went back to the hull.
We placed the saw on the hull, made a cut, and it went straight through the wood. A bummer, we thought, because, well, there weren't any screws there then. We made another cut, and then we saw that there were screws, also in that first cut. The saw went through multiple screws, so it went through like butter. We checked the teeth and there weren't any damages. All the teeth were still there. It was great, so we were quite relieved with this outcome.
For all future design work, and also to come up with a good plan on how to section the hull so it fits in that container with the least cuts possible. Ideally, I could work in 3D. Because we had no good drawings, the only alternative is to make a 3D scan. For this, we contacted Mark. He brought his Leica.
This is a Leica RTC 360, a $100,000 piece of gear. It shoots 2 million invisible laser beams per second and has party mode if you can see in infrared. Kind of like the LiDAR on an iPhone 12 Pro, which projects a measly 576 dot matrix. This device in comparison throws 366 million dot equivalents in a 20 meter or yard sphere on a 3mm or 1/8 of an inch grid. Since the scanner knows its azimuth and elevation at every beam, it can do some trigonometry math, oversimplifying things quite a bit so we don't have to think angles or spherical coordinates. The scanner basically already knows where it shot the laser in 2D. So what it still needs is the distance to that point. Some of you might now think it can just use time of flight, where it measures how long the light takes to go out and come back, then multiply by the speed of light and divide by 2 to get distance. But there's a problem with that. Say the object is 5 meters away. The round trip time is 33 nanoseconds. To put that in perspective, a 1 GHz processor has a 1 nanosecond clock speed, in which light travels a foot, and there are other delays in electronics. The scanner accuracy is a millimeter or 3/64th of an inch, so that by itself won't do. So they also do this super clever thing called the phase shift method, where the laser's intensity is modulated. The returned signal comes back with that modulation phase shifted by the travel delay. By comparing the sent and received modulation phases and some other advanced trickery, combined with the time of flight, the system can calculate the distance and we have the 3D coordinates.
And that is how this amazing and cool technology works. Mark completely over-delivered, well beyond his assignment. He scanned out and in, top and bottom. It was really cool to see the hull come to life in this tablet.
Comparing it to my own scanner and registration software experiences, it worked like a dream. It all behaved so nicely, fluent and lightweight. Remember, this is only a tablet.
Vooruit. Onder de bocht.
These scanners are mostly used for projects like industrial plant modifications, architectural work, or documenting archaeological sites. Here, every red circle represents a capturing position.
As I said, he absolutely over-delivered because he even gave us within 2 weeks a small surfaces model that we could straight away use to plan our sections, our cuts. We were finally able to see the hull next to a 40-foot high cube shipping container, and what a shock that was. Because as large as a 40-foot is, it was really tiny compared to the hull.
This was the section I struggled with most while writing this video. I'll try to explain. We have a vision for this channel. It comes from watching Discovery Channel and National Geographic as a kid. Back when you could tune in at any hour and learn something interesting. It was the era of documentaries, technology and the outdoors about 30 years ago, before scripted reality shows took over TV. We want to make long-form content that's entertaining and relaxing without wasting your time. A balance between educational and engaging. We respect your intelligence and that natural urge to learn, so we try to keep it real. We don't want to dumb things down or cut every visually boring part or inflate things. But with hundreds of hours going into an episode, of course we want growth and also need to please that YouTube algorithm. But we also want to make something for people with a healthy attention span. So that's why this part was so hard to write. Making the saw plan took months. Not just months sitting at the computer non-stop, but months of mental effort. In the shower, in traffic, when I was supposed to be asleep. In 3D CAD, I made so many versions and redos that my file management turned to crap. After version 30 or so, I gave up on that, and progress came just from learning what didn't work. The assignment sounds simple. Drop a container-sized rectangle on the hull, call it piece 1, and then keep on going until everything fits inside. But there were so many requirements that it became a difficult puzzle. And deciding to cut something up doesn't mean we don't care. The plan had to be the best I could make it. I tried to write about line laser versus chalkline and why SolidWorks is a terrible tool for packaging weird boat parts and why I didn't switch software, and how a shockingly long list of non-obvious and conflicting requirements shaped the plan. It all felt important to tell you, but it just wasn't interesting enough. So the part that probably took the longest and was one of the hardest to do will stay underexposed in this documentary, as mostly a time-lapse of me sitting behind the computer.
At this stage, we only had 1 month left until the deadline, but luckily the cutting plan was ready, so we went back to the hull to draw those cutting lines onto it.
Upon arrival, armed with our pencils to draw those lines, we were greeted by the sight of a large piece of heavy equipment, a telehandler. And it was parked straight in front of the entrance of the shed.
But what we didn't yet know is that the equipment that was parked in our way, and mostly their owners, became the very best thing that could have happened to us here. Here's the final plan. I guess the simplicity is a reflection of the efforts put into it, just a handful of elegant lines and some dimensions. Well, either that or I'm just a crappy engineer who loves to complain about how difficult things are, or a bit of both. The method of marking the hull for cutting was to first transfer all the start and end points of the cut lines to the hull using a tape measure. Then came the laser level to literally connect the dots. And if it weren't borrowed from my dad, I would have ripped out that buzzer. Holy shit, it got annoying. I only had to rig the laser to a forced tilt for the most forward sectioning, which trims off the bow at an angle. During design, I made sure to keep all other sectioning lines the result of projecting either perfectly horizontal or vertical planes. The rest of the process was quite simple. Just draw over the laser line, move the ladder 100 times and trying to remember to reposition the camera. Here you can see how a flat plane intersecting a double curved surface can give a bendy line. It was something that I had to consider during the design because circular saws only like to go mostly straight.
Now another issue, because the screws that we told you about weren't the only screws in our way. I made you a drawing to better explain.
Here's the finished deck, upside down, already fiberglassed on both sides. On top of it, 17 hull-shaped frames were positioned. They were placed where the original drawings, which are now forever lost, had defined the so-called stations, which are hull cross-sections at fixed intervals. Then the strips were bonded in place and internally screwed into the layer before them, just like I showed you earlier. To pull the strips tight against the frames, countless screws were driven straight in at 90 degrees to the hull surface, through the planking and into the frames. The frames themselves were made from thin wooden strips laminated together into strong curved forms. And their outer faces were covered with masking tape to keep the epoxy from bonding to them, which I of course forgot to illustrate. As the planking went on, a lot of the epoxy naturally squeezed out of the joints. It got onto the tape, past the tape and everywhere else. That created some surprisingly strong bonds, and later those had to be broken loose by force or cut apart with a saw. You can tell the screws were driven in hard. The wood was soft enough that most of the screw heads sank deep into it. Then, over time, with the help of high humidity and leaking water, many of those screw holes mostly closed back up by the wood expanding back to its original shape. After screwing, the hull was sanded smooth and the holes were filled with wood dust. So, the deeper a screw had gone in, the harder the head was to see and the harder it was to reach. Oh, and the best bit? About half the screw heads were already nicely rounded out, so more sawing required.
This is the moment you've been waiting for. We've got the demolition blades, we've got the 3D model, removed 1 million screws, ordered a shipping container. We've only got a few weeks left until the deadline, but today was going to be the day that we're going to make the first cuts.
The first part we were going to remove was the bow.
2 symmetrical halves that had to be sliced in the middle, trimmed off the hull and also sliced away from the deck. It's actually quite impressive that the saw just eats all the stainless it encounters. All you notice is that the RPM drops a bit. The ladder here was still somewhat stable, but eventually we had to find ways to tie it down a bit. The base had barely any grip on the concrete. The hole was very slippery, shaped like a slide and smoothly sanded and dusty. As a safety measure, I tied a rope to the roof structure and wrapped my waist to prevent free falling all the way down. I do have to admit that it was a bit unnerving to cut into the structure I was sitting on, but we strategically kept bits of the cut line connected on purpose until the actual removal. Here you see me struggle with the topmost part of the cut, which ended up a bit too curvy for the saw. Trying not to forget about the camera was also important, because it needed repositioning and periodic checks if it was still recording. The white dots you see here is where the screws were already removed and the holes fillered. Of course, we found out that tens of such screws weren't actually removed and fillered over. Some parts of the hole were like that. At this point, not yet knowing why, I started to notice the saw getting progressively harder to push. It came from the gradual buildup of epoxy smear on the sides of the teeth. I had also arrived at the toughest bit of the hull, the cutwater. It's called like that because it files taxes. If I remember correctly, it's a piece of mahogany. There were some beefy non-stainless fasteners inside, as you can tell by the sparks. I was also still unaware that it started to stink out of the vacuum cleaner. Yeah, a lot of resistance here. I still wasn't aware that the teeth were now totally gummed up, as I contributed the friction to the hardwood and maybe the structure releasing tensions by clamping the cut. Now I'm alternating between trying to cut away the forgotten and rounded screws and epoxy leaks and dividing the cutwater, as it is much thicker than the circular saw could reach. Quite a few reciprocating saw blades were consumed just on the bow and shortly after the first saw died.
Alles is nog echt helemaal scherp.
In the beginning of this video, I talked to you about making our favorite recipe. The ingredients we'll be getting first. They are only available a couple of months each year.
Ja. Oh jee. Ja.
Is er nog plek?
Ja, wat ook erbij.
Ja. Ja. Hoi.
Komt toch niemand vandaan?
So we are here at the field where the asperges are growing. Behind me, one of the farmers is explaining everything about this. I really hope that we can harvest maybe one of the spears ourselves. So let's go have a look. These asperges, they stay white because they grow also underground and underneath all this plastic. And that way they stay tasty and sweet and very tender. So we are going to dig up the asperges ourselves now. I see their little heads sticking out there.
What?
I see the little heads, the white heads. What you see here is that it has this cutting tool to cut away the asperges without even touching the soil. So grab the tip, cut it, takes some force because at the bottom they are quite tough. So that's actually quite difficult then.
Yeah, you don't feel anything.
So he just explained how the harvesting is done. They have a machine that pulls up this plastic and also has buckets in it. You'll have people feel with the tool where the asperges is. And then they cut it and then pick it up and place it in the bucket. Even taking away only one of these took quite some effort. That also explains why this is called white gold. It's such a labor-intensive process.
Everything is done by hand. No machine picking it. That's a lot of manual labor. Every day.
But tasty. So we are here on the asperges field together with Piet. He is doing this work already since 1987. What's the difference between back then and now?
In de tijd moest je alle asperges zien als ze nog onder de grond zaten. Toen hadden we deze folie nog niet, dus was het veel handwerk. En nu kunnen ze boven de grond komen en dan kunnen ze toch witte asperges oogsten.
There is a AA en AAA asperges. What's the difference between those?
Verschil is alleen de dikte.
Oké.
A is een pinkdik.
Ja.
AA is vaak wat een restaurant gebruikt. En AAA is een extra dikke. Qua kwaliteit is het hetzelfde. Alleen de dikte verschil.
Okay. So for people that are buying asperges in a supermarket, what should they look for?
De asperges moeten in ieder geval niet verschrompeld zijn. En de onderkant moet niet ingedroogd zijn.
Ja.
En als ze tegen elkaar wrijven, moeten ze piepen.
Piepen.
En als ze niet meer piepen, dan zijn ze echt oud.
Dat is wel een goede tip.
Something I didn't know.
What's the most tastiest recipe?
Ik heb graag asperges met een klein stukje zalm erbij.
Ja.
Maar ook het traditionele van asperges met een eitje, wat ham en wat krielaardappels.
Oh ja.
Is ook heel lekker.
Wij gaan straks hier ook asperges kopen en daar gaan we dan soep mee maken.
Voor een soep kun je eigenlijk vaak of stukken kopen of krommen. Ja, voor soep kun je allerlei asperges gebruiken.
Dankjewel, leuk. The Netherlands is one of the most intensive white asperges producers relative to its size. Hoppa. Hey, dankjewel. I did not harvest enough asperges on the field, so we gonna have to buy some more here. And then make some delicious soup. First, the asperges gets placed on the conveyor by hand, one spear per slot. It gets washed and cut to length. After that, 6 photos are taken of each spear. The computer checks thickness, straightness and weight, and if the tip is pink or white, then it decides which of the 18 bins it's dropped in. The fully automatic sorting machine this farm uses can handle around 30,000 spears an hour.
Kan ik u helpen?
Ja, mag ik zou wel van deze willen?
De smaak is vooral asperges.
En dan iets van 750. Ja.
Alsjeblieft.
Dankjewel. Een fijne dag. Doei.
We'll show you how to turn these into the most delicious soup you've ever had, I promise, later in the video.
I roughly positioned the lifting holes in the center of mass so that the pieces would be easy to manipulate and behave in a predictable way. You can see a good example here of how the universe had some things planned out for us. We didn't film this, but originally the seller had an old forklift truck that we could use during the disassembly, but it ended up unusable after not having been started in many years, and I had no time or desire to fix it. We already started looking for a rental, but Giovanni, his dad, and their friend Zappa, they offered us to help us out and also use their telehandler. I really can't express how lucky and grateful we were with our new friends and that they could spare time to help.
I think it's easy for you to imagine how relieved I felt when that first piece of the hull was safely put down without incidents, without breakage. It was just a very happy moment. But at the same time, it was one of the smallest pieces that we had to cut and maneuver. So yeah, but let's get back to that delicious soup.
We're going to make the asperges soup with these, of course. It's quite an easy recipe and it's really tasty. So we are going to use some water, chicken stock, butter, flour, heavy cream, eggs, and we like to finish it off with some nutmeg. So now I'm going to peel all these asperges, and I'm not going to throw away all these peels because they are very tasty if you start your stock with these. Lay them flat on the board, start around 6 centimeters below the head, and then turn the asperges while peeling. You can see that you've taken enough away because the inside is shiny. So now the peels go in the pan, and I'm also going to chop off the ends of the asperges. These are quite woody and we don't want to have those end up in the soup. The older the asperges are, the more you have to take off, but still try to take as little off as you can. I normally start with only 1 centimeter and then see if it's still woody and if I have to take off more. And the rest of the asperges I'll chop into bite-sized pieces. I'll put in about 1 liter of water. And this is used to cook the peels and later on also the asperge pieces. Now it's boiling, bring the heat down so it's just a simmer, and then cook it for 10 minutes. It's starting to smell already really good here. I'm going to strain the asperge peels and put the hot water with the asperge pieces. So you saw me using a strainer and a sieve. The strainer keeps the peels from falling into the pot. In the flowers there can be a little bit of sand, and the sieve keeps it from getting into the soup. I'm going to boil the asperge pieces for about 10 minutes. So while the asperges are boiling, I'm gonna cook the eggs as well. I like them soft boiled, but you can do them however you like. I'll cook them about 7 minutes. The asperge pieces are now done boiling. I will strain them in another pot using the strainer, and I will put in some highly concentrated chicken stock. You could also use actual chicken stock, but then boil the asperge pieces from the beginning in that. I'm going to make a roux. I've placed the heat on medium, melting the butter.
You have to use lots of butter because that's what makes it taste deliciously good. And let's be brutally honest.
Butter, melting the butter.
A life without butter is not a life.
Don't let it turn brown, we don't want that. I will then start adding the flour bit by bit and then keep on turning.
Stirring.
Give it a nice turn.
Now we give a nice turn.
So make sure that you scrape the bottom really well. We don't want this flour to stick to the bottom and burn. Make sure that it stays nice and yellow. It cannot turn brown. So now it's starting to smell a little bit like cookies. I'm going to stir it a little bit more and then start adding the chicken stock bit by bit. Get your head back. In the meantime, you have to keep stirring. I will add the final bit. If you sometimes tilt the pot, you might still see some lumps. As long as these aren't brown, you're still doing good. Just keep on stirring and trust the process. I will bring this to a simmer. So now I've got a smooth roux. I will start adding the heavy cream. I'll keep stirring until all the cream is mixed. I will bring the heat up to medium again to have the soup start simmering. I don't want it to boil because you don't want any of this to be sticking to the bottom of the pot. Once it gets burned, it will give a bitter taste to the soup, and that you cannot restore anymore. So after a couple of minutes, it's done simmering. I'm going to add 1 tablespoon of parsley. We are using frozen one, but you can also use fresh parsley. And then stir that in as well. So next I'm going to add the nutmeg. We like to grate this ourselves, but you could also use powdered one. I'm using a microplane for this. It's a great tool. I recommend you to get one as well. Just be careful not to strip away your fingers. 5 or about 10 scrapes. You can do whatever you like. So now the soup is almost done. We only have to add the asperge pieces again. Stir it together. Be careful with this because these asperges are quite fragile. You don't want them to break up. So now it's all finished. Let me tell you one secret. The tips are the tastiest. So you can give those to yourself or to the one you love most. A little bit for Chin as well. Okay, all done and ready to eat. White asperges are less common in other countries. You're most likely to find them from April to June, so if you spot them in your store, definitely grab some to make this soup.